Okay, question 1 says match the graph up, and what we need to do really is to look at each of these graphs and see what they look like. Y equals 2 times 2 to the x. If we just substitute a few points in, we should be able to find out which of these graphs it is. So if x is 0, 2 to the 0 is 1, 1 times 2 is 2. If x is 1, 2 to the 1 is 2, and times 2 is 4. So we're looking for a graph that goes through 0, 2, and 1, 4. If we come down to graph D here, there is the 2 points we want. And let's just check. It's got 2, 8. So if x was 2, 2 squared is 4, times 2 is 8. So graph D is A. All right, so just by substituting, we should be able to find out which graph it is. So try B, C, D, and on your own. You can do question 2 now, just so you can try it and see what you think. So question 2 says, sketch the graph of an exponential function has domain all real numbers. Well, most of them do anyway. Range y greater than 0, so that means that we must, well, that's not very good. That means that we must have a asymptote in there somewhere, and we'll just put the asymptote in green. If we can get green up, we can indeed. So the asymptote is y equals 0, and we know that the range is above this at y greater than 0. It says there. Y-intercept 5, so we've got 5 there. And the function increasing, what does increasing mean? Increasing means if you look at the graph from left to right, it keeps going up and up. And that would be a graph that fulfills all 4 of those there. Question B is interesting. Is this the only graph possible? Well, the answer would be, of course, no, because we might have a graph that goes a bit shallower through 5, and therefore it's not unique. Okay, try 3 on your own. So we know the graph here has the point 0, 4, 1, 8, and 2, 16, and we're looking to fill the equation y equals a b to the power x. If we were to substitute x equals 0 in to this equation here, if x was 0, b to the 0 is equal to 1, and then a times b to the 0 would equal a. So therefore what we're saying is that if x is 0 here, a is 4. So the y-intercept, that point there, is your a value. So a, in this case, equals 4. So now we've got y equals 4 times b to the power x. Now we look at our y values. Our y values are 4, 8, and 16. What are they increasing by? Well, it looks like it's 2. 4 times 2 is 8. 8 times 2 is 16. That is our b value. So the final answer is y equals 4 times 2 to the power x. And of course we can't multiply the 4 times the 2 to make 8. We've got to leave it like that. Question 5 here is exactly like we did question 4. I'm sure we can try that on our own here. What we're going to do is have a look at question 6. And we've got a radioactive sample with initial mass of 25 milligrams has a half-life of 2 days. What you do know, there is a formula here that says that B equals T over D. And D is the half-life. D equals the half-life. This is a standard formula. It's not in the book, but it makes this question much easier. So the half-life is how long it takes for something to decay, i.e. if it starts at 25 milligrams, the half-life will be it takes 2 days to become half the weight, i.e. 12.5 milligrams. So again, we've got this formula. The A will be the initial mass. So we know that A is 25. What's the B value? The B value is what's multiplying each time. Well, it's half each time, isn't it? We are halving the mass each time. and t divided by, what is the half-life? The half-life is 2, so therefore our answer is C. Going to have a look at question 7 here, and we're going to graph A, which is f of x equals 1/2 to the power x. And we're going to start off by doing a little chart of numbers. So we'll do our usual -3 to +3, and we'll find some answers. Start off with 0 first, the easiest one. If x is 0, 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. And 1/2 cubed is 1/8. What's a half to the -1? Well, let's have a look, see what that is. 1/2 to the -1. We flip the fraction, and that gives us 2/1 to the 1, which equals 2. So the fraction just flips. 1/2 to the -2. Again, we flip the fraction, so it's 2/1 to a positive power, which equals 4. And in the same vein, this will be 8. Graph this out, just a quick graph here. Let's go 1, 2, and 3, 1, 2, and 3. And we've got, let's go, and we've got the scale here. We've got all the way to 8, we'll put 8 up there. So we know that 0, 1, 1/2, 2 1/4, 3 1/8. So they're going to -1, 2, -2, 4, and -3, 8. So this graph comes down here like that. Question says, find the domain. Well, the domain of this is going to be all real numbers, as a lot of these things are. Range. Well, we do have an asymptote, which is going to be y equals 0 in this case, as you can see. So therefore the range is going to be y greater than 0. Intervals of increasing and decreasing. Well, it's decreasing. If you go from left to right, it is decreasing the whole way. So basically from -infinity to infinity, it is decreasing. And what you'll find with a lot of these exponential graphs, they either increase or decrease the whole interval. And of course the asymptote we know is y equals 0. So have a go at B and see yourself. Just have a quick look at question 8 here. We've got two functions. 2 to the power x looks like this. That shape there coming down. We know that. And 2/x looks like this. So are there any similarities here? Let's have a look. We know the domain of 2 to the x. And this one's 2/x. So the domain of this one is all real numbers. The domain of this one is x does not equal 0, so all real numbers except 0. The range of this one we know is y greater than 0, and the range of this one is all reals except 0, so y doesn't equal 0. Asymptote for this one is y equals 0, and there's two asymptotes for this one, y equals 0 and x equals 0. So we'll just put those in green as usual. So there's the asymptote for 2 to the power x, and this one has two asymptotes there and downwards at x equals 0. It says, now B says, describe how the graphs are alike, how they differ, compare the asymptotes of these functions, what do you observe? So there is similarities and there are differences. Question 16 here, gone to green, we'll change that. So you've got 3x minus 2 to the power x minus 1 equals 0. So if we take the 2 to the power x over, we get that. And what we need to do now is graph both these functions. So we're going to look at y equals 3x minus 1, which we know has a y-intercept of -1 and a slope of rise over run 3, 1. So that is a straight line graph, like that. And then if we look at 2 to the x, we know that 2 to the x goes through 0, 1. It goes through 1, 2. And that graph will come down something like this. And there'll be an asymptote. Let's do that again, like that. And it goes something like that. And what we're looking for is the two intersections. I think there should be 2 intersections, maybe one up here as well. The only way you can do that is on your calculator. So get your calculator and try and find that out. So y equals 12 times 1/2 to the x minus 3. And we're going to find the y-intercept. Well, the y-intercept is when x equals 0. So if we substitute x equals 0 in there, 1/2 to the 0 is 1. 12 minus 3, 12 times 1 is 12, minus 3 is 9. If we plug y equals 0 in, see what we get. So we add 3. Divide by 12, 3 over 12, equals 1/2 to the x. And 3 over 12 is 1/4, which is 1/2 to the x. And we know that 1/4 is 1/2 squared. So therefore, x equals 2. You've got 2 similar equations. That equals that. So therefore 2, 0. So the x-intercept's 2, and the y-intercept is 9, and therefore the sum of a and b must be 11. 9 plus 2 equals 11.